Hi, and welcome to another in a series of technology-focused videos brought to you by the team at K2 Enterprises. My name is Tommy Stevens. I'm one of the partners at K2 Enterprises, and it will be my pleasure in this session to share with you the relatively new LET function that has recently appeared in Excel. And when I say recently appeared in Excel, I'm talking July of 2020 if you're in a Microsoft 365 or Office 365 subscription-based version of Excel. Now, if you're not in one of those versions of Excel, particularly if you are a subscriber to an Office 365 or a Microsoft 365 plan, look for LET to be rolled out to you sometime over the next several months. And if you are in a perpetual license of Excel, such as Excel 2019 or Excel 2016, it appears as if you will have to wait until the next perpetual license release of Excel in order to obtain LET and other new functions that Microsoft is rolling out. Okay, so with that said, let's get started and begin discussing what LET is all about and how it can help you, how it can make your life a little bit simpler and easier by making it much easier to work with more complicated, more sophisticated formulas. As we get started here, first off, let's understand what LET exists to do. LET is a function available in Excel that allows us to declare one or more variables within a formula. And then once we declare those variables inside that formula, we can use that variable multiple times within that formula. And I need to emphasize that for just a moment because you cannot use LET to declare a variable within a formula and then attempt to use that variable outside the formula. Everything has to be, shall we say, self-contained within that formula. Clearly, as you will see, LET is not right for everyone. There will certainly be instances where you will not need to use LET, but if you have specific cases, for example, where you're using the same calculation multiple times within the same formula, then that's a very clear example, a very clear illustration of when LET is going to be useful to you. A couple of other quick points here. When we're talking about using LET to declare that variable, understand that that variable could be a simple constant, such as $50. It could be a cell reference to something else within that Excel workbook, or that variable can actually be a formula itself. For example, maybe a formula that uses Excel's payment function. That might be something that you utilize multiple times within the same formula. You could set that up one time, declare it using LET, and then use that LET created variable to insert that formula effectively multiple times within the same calculation. And in doing so, that's going to make that formula the overall formula that is going to make that formula much more concise, far fewer number of characters, and far less chance of error. And so those are going to be some of the benefits, of course, of working with LET. LET's going to be very helpful to us when we need to use the same calculation repeatedly in the same formula, as I was just touching on, such as oftentimes happens when write formulas that use if functions. And you'll see a very good example, a very clear example of that in just one moment. Now recognize you can also do this with defined names, and perhaps you might have done this with defined names in the past, but the defined names are not created in the formula itself. And we can create a pro and con scenario for using defined names for this same purpose. The pro would be, once I create that defined name, whether it's referencing a variable, a constant I should say, or whether it's referencing a formula, I could then use that defined name anywhere inside that workbook. And let's compare and contrast that with the LET function for a moment. When I'm using the LET function, I can only use that declared variable inside the formula that contains the LET function. So there's a little bit of compare and contrast between defined names potentially in use for the same purpose. Getting into the syntax for a LET formula. Here you see it. It's LET followed by name1. So whatever you're going to give the name of that first variable, first constant, first formula, followed by the value, including a formula if indeed that's what you wanted to do. And then we can get into name2, value2, name3, value3, name4, value4. We can extend that out, as you will see momentarily, up to 126 names and values. So I doubt any of us would really ever need more than 4, 5, or 6. But if you did have that extreme need, yes, indeed, you could use the let function to declare up to 126 names and values within the same formula. And then once you declare all of those names and values, you can use them in any other formula, any other calculation that you might want to embed inside this let formula. Okay, sounds kind of vague, sounds kind of challenging here at first, but I promise you through the use of some examples in a moment, we're going to make this pretty clean for you. Referencing again, the values can be constants. They can be cell references to other things in the workbook or even things outside the workbook, or they can be formulas in and of themselves. So this kind of helps us understand just a little bit about the syntax of a left function. With that said, let's go ahead and get into some examples and show you how you can begin to take example of left. As you can see, I've toggled over to an Excel spreadsheet, and that spreadsheet currently has 3 constants already sitting in it in cells B2 through B4. Let's now use a left function to begin to incorporate each of those constants into some type of calculation. So as you can see, I've clicked in cell B6, and I'm going to begin my let-based formula with equals LET. And I'm not feeling very creative at the moment, so I think what I will do is give the first name the value, if you will, of A. Okay, so my first variable I'm going to call A, and I'm going to set A equal to the value that's in cell B2. Now I'm going to go and assign my second name, and my second name is going to be B, and I'm going to set that equal to the value that's in cell B3. And then finally, I will set my third name up as C, and I am going to set that to the value that's in C4, but wait a minute, I really don't want that to be just C4. I'm going to add a little multiplication there, and we're going to say C4 times, let's say 75%, for example. So now I have 3 variables, A, B, and C. And those variables are essentially 50, 100, and then 75% of 150. Would actually help if I built that formula correctly, right? There we go. So 50, 100, and 75% of 150. And let's assume that those are the only 3 variables that I want or need to create in this case. So now I'm going to build a calculation that says A times B times C. So we've declared 3 variables, and now we're going to multiply those variables by each other, and as you can see, we get the result of 562,500. Now, we'll see a more practical illustration of let in just a moment, but for now, what I want you to experience is what happens if we go and change one of these numbers. Let's change the 100 to 1,000, then obviously our formula updates in real time. So, probably not a lot of benefit from a practical perspective of using let in the manner that I just showed it to you, but rather I start with that simple example to get you accustomed to the idea of declaring a variable and then associating that variable with a cell reference or perhaps a constant in some cases, or as I did in this example, taking the variable that we assigned to the letter C and building that out as a formula of B4 times 75%. Now let's turn our attention to perhaps a more realistic use of let. Now, as you can see, I have jumped over to another Excel workbook which contains a very simple payment calculation. In this case, we're looking at a principal amount of $400,000. We've got an interest rate in place of 3% on an annual basis. This is going to be a 30-year term. Let's extend this example, though, by making the following assumption. Let's suppose that the bank or the lending institution charges an extra 0.5% interest on an annual basis if the customer's credit score is below 800. Now you can see in the illustration as it currently stands, the customer applying for this loan has a credit score of 820, so they would not be subject to the 0.5% increase. But I want to build my payment function so that it takes into account the customer's credit score and adds the 0.5% increase for any customer who has a credit score of under 800. For example, notice in this illustration when I go and change the credit score to 799, the payment increases, although nothing else, none of our other assumptions increased, at least not on the face of the spreadsheet, but in reality that 3% that we're looking at has indeed popped up to 3.5% because of the credit score. And then, of course, once I change that back to 820 or anything 800 or above, we remove the 0.5% increase in the interest rate. How is that happening in this case? Well, let's go take a look at the let function that is driving the formula calculation. Notice up front I have established the name for my first variable of rate. And then I have used a formula which includes an if function to calculate that rate. And it's basically saying, okay, let's go look at cell B4, and if B4 is greater than 799, then we want to take on the value of B2. That is, we want to let rate equal the value that's otherwise in cell B2, which is presently 3%. But if that test fails, that is B4 is not greater than 799, all of a sudden our interest rate is going to take on the value of cell B2 plus the 0.5% increase. And so it's this if statement then that is driving the calculation of the interest rate and associating the interest rate with the name entitled rate that's being declared in the let function, or being declared by the let function, I should say. And then finally, having established that variable of rate, we insert that variable into the payment function that's sitting out here on the far right-hand side of the formula. And this is Excel's ordinary payment function. Hey, Excel, do us a favor. Go take that rate, the interest rate that was just calculated for us, divide that by 12, and then let's multiply that to let's apply that to a 360 payment loan based on the principal amount sitting in cell B1. The payment function here isn't really the teaching point. It's using the let function to calculate this rate for us. Now, in this example, using the let function provided a moderately smaller formula than I would have otherwise had I chosen to do this with if functions. I could certainly have done this with if functions, and I'll show you the if function formula in just a few moments. But for now, what I want you to understand is I believe in this case I saved only about 5 characters. This formula is 5 characters shorter than it is if I had used if functions exclusively and not used the let function. Where we really begin to see benefit, however, is when the scenario becomes a little bit more involved. Maybe instead of this 2-tier credit system, we have a 3-tier credit system. And in a 3-tier credit system, all of a sudden my formula using the let environment is going to be significantly reduced as compared to what it is in the 2-tier system. In fact, as you can tell, I have some hidden rows over here. Let me just go ahead and unhide all of those rows. And let me unhide all of these columns also, which help to explain some of this to us. So let's unhide. And let's focus next on the left function if indeed we have 3 tiers. My, that got really busy all of a sudden, did it not? Let's actually go back and hide a couple of those rows. My apologies. And so now we're going to look at what that let function would be like if we had a 3-tier credit structure in place. The first tier is still if the customer's credit score is over 800, they get the standard rate of 3%, which is, as you can see, referenced there in cell B2. But if their credit score is between 750 and 800, they are going to have to pay a 0.5% penalty. And then if their credit score is anything under 750, they're going to have to pay a 0.1% penalty. So they're going to pay an even higher an even higher interest rate than what they otherwise would have had to pay. Again, we're using the let function here. As you can see, there's our let function. We're using that let function to help us decide what the appropriate interest rate will be in this case. And that interest rate is is being defined with the name of rate. And then we take that amount and we incorporate it into the payment function. Now, what's notable about this is in this 3-tier environment, this entire formula that you're looking at is 77 characters in length. Now let me go back and unhide all of those formulas that I had previously hidden so we can see what it looks like across the board. Comparing the two-tier credit structure, if you will, and that would be the two shaded rows. If we used if functions on that two-tier credit structure instead of the let function, we would have saved 5 characters. That is the difference between 58 and 63 characters that you currently see highlighted. However, notice that when we go to the 3-tier credit structure, using the let function, the total length of the formula is 77, but that is substantially smaller than the 102 characters it would have otherwise taken in order to generate those same results with an if function. And why is that? That is because if we're using the if function, notice how we have to continually repeat the payment function, the payment function portion of the formula. We have to repeat that one time for each and every one of the scenarios. But when I'm using the let function, I only have to insert the payment function into the formula one time. But because I'm not having to use 3 if statements to determine, or 2 if statements as the case might be, to determine what the appropriate interest rate is. The let function is essentially doing that for me. Now, I certainly recognize that there are probably other ways we could have tackled this particular problem. However, I wanted to use this as a very, hopefully down-to-earth demonstration on how the let function can help you simplify your formulas in Excel. Remember, not everyone has access to this feature yet. Again, this is relatively new, summer of 2020. If you are running Office 365 or Microsoft 365, you either presently have it or you should expect to receive it in your next update cycle. Again, those of you who are running perpetual licenses of Excel, you will likely not have access to this feature until you do your next upgrade, which presumptively would be with the Excel 2022 release. As you can see, Excel's let function offers a tremendous amount of promise and potential. I hope that we've been able to give you a good introduction to how you can take advantage of this function. As it becomes available to you, let me encourage you to seek out situations where you can indeed use let to its fullest potential. On behalf of everyone at the K2 Enterprises, we thank you for stopping by. We hope that you'll come back and join us again soon. Once again, thanks so much.